All right. Here's 15. That one? Yes. Now, shh. Be quiet. Which letter do I want to get by itself? Y. Which Y? The one on top. Because it's the one that has a 1 in front of it. Now, how do I get this Y by itself?
You add it, subtract it, what? Other side. Add to it. Oh, no, you subtract it.
Actually, I would add Y. Because what do you want to do? You want to get the Y positive, right? So if I add, it's not that I can't do the 2x, but if I add Y, it'll go to the other side and it will be positive. Right? But that's what I really want. So I'm going to take this and add Y, and they're going to cancel. That will leave me Y minus 1 equals 2x, but it gives me a positive Y. You can move the other, but the Y is negative, you still have to change signs. That's fine. If you move the Y, it's positive. Now what do I have to move? The negative 1. So it's plus 1 plus 1. So now I have Y equals 2x plus 1. Yes? Because we don't write it that way. When we graph, we write Y equals mx plus b, right? So the best thing to do is write it that way most of the time. Just so you don't have to realize, oh, this time I have to do it. And other times I don't care. If I always do it this way, and this probably doesn't really matter. But if I do it that way, always, I have it right when I do graphing also. Okay, so what do we have? Y is equal to this, right? Where am I going to put this? In place of the Y in the other equation, right? So this is the other equation. It's going to go there. So I have 8x minus 4y, which is a parenthesis, and this is what goes inside of the parenthesis, equals negative 4. All I did was copy this over exactly down here, except I took the y out and put this in place of it, because y is this. And now I'm going to distribute. 8x, what's a negative 4 times 2? Negative 8y. And negative 4 times 1? Negative 4. Because negative 4 times 1 is negative 4. Now, what's 8x minus 8x?
0.
They cancel. So what do I end up with? Negative 4 equals negative 4. When the letters are gone, and the two numbers are the same, what's my answer?
What's that called? No solution? There you go.
Wrong.
There's a solution.
All
real numbers.
Real numbers.
So is the slope 1 over 1 then?
When is this true?
Always.
Always. Does it matter what x is?
No.
No, because there aren't any x's in the problem. If x is 1, this is still true. If x is 2, this is true. If x is 10, this is true. It doesn't matter what x is. This is true because there aren't any x's. Yes?
So that when you always substitute anything, it's just all the numbers.
Anytime all the letters disappear, anytime all the letters disappear and all you have left is numbers, you have two possibilities. One is this one. The two numbers are equal. If the two numbers are equal, it doesn't matter what x is because there aren't any x's. This is always true, and therefore it's all real numbers. Okay? There's a second possibility. 8x minus 8x plus 5 equals 4. This isn't down the problem. I'm showing you the other possibility. What happens to the 8 x's? What's this? True or false? Does it matter what value x is over here? These are always false, right? When is 5 equal to 4? Never. 5 is equal to 4 always? Okay. 5 is equal to 4 never when all the x's are gone, all the letters are gone, and all you're left is two numbers that are equal, that are not equal. This is a false statement. They are not equal. What's my answer? No solution. When are these equal? Never. Does it matter what x is? No. 5 is not equal to 4. There's no x's in the problem, so I can't change anything. The value of x doesn't change this situation. So no matter what x is, 5 is still not equal to 4. So this is no solution. When the letters disappear completely, if the numbers are not equal, it's no solution. If the numbers are equal, then it's all real numbers. Only when the letters cancel out and are gone, and there are no letters left. As long as there's a letter in the problem, this can't happen. You're going to have a normal number, unless the letters all cancel.